Okay, 5-6, finding rational zeros. When we find rational zeros, we have something called the rational zero theorem, okay? Here's what it is. It gives us a starting spot, but it might give us a very wide starting spot, and then you better be good at guessing, is what I'm going to tell you. Okay? So it gives us a starting spot as to, hey, these are all the possible things, possible zeros I could have in this. Now let me just use synthetic division to figure out what they are. You take the factor of the constant term, okay? And you put it over the factor of the leading coefficient. So the factor of the constant term up here in this is 105. The leading coefficient is 64. So you're going to take all the factors of 105 and put them over top of all the factors of 64. Now, when you factor 105, let's just give an example that's easy. 1 and 105 is a set of factors, right? Okay, but you have to remember that it could be plus or minus 1 and plus or minus 105. Okay, what else would go into it? 5, right? So another factors of 105 are 5, plus or minus 5, plus or minus 21. But you're going to list them over top of all the factors of 64. Plus or minus 1, plus or minus 64, plus or minus 8, plus or minus, and you're going to keep going. Okay? So we're going to practice with just listing factors to start with. List the possible rational zeros of f using the rational zero theorem. What is my constant term? What is your constant term in this? 12. What's your leading coefficient? What are all the factors of 12? Plus or minus 1, right? Plus or minus 2, plus or minus 3, 4, 6, and 12, correct? Now this is easy because the bottom is just plus or minus 1, okay? So all of my possible factors in this case are these whole numbers because they're over top of 1. So plus or minus 1, 2, 3, 4, 6, 12. That's what they want when they say list all the possible zeros. Okay? That one was easy because the bottom does not have something that makes a fraction. Okay? In the last lesson, 5.5 yesterday, we found zeros of polynomial functions when 1 zero was known. The rational zero theorem is a starting point for finding zeros when there are no zeros known. Okay, so this is when they don't give you a zero. However, the rational zero theorem lists only possible zeros. In order to find the actual zeros of a polynomial function, you must test the values. This is where being a good guesser comes in hand. Okay, because if not, I could test each of these values before I find one. You get what I'm saying? Okay, so here we want to find all the real zeros of this function. Find all the real zeros of x cubed minus 8x squared plus 11x plus 20. Okay? So I have x cubed minus 8x squared plus 11x plus 20. Now, this one's nice again because my leading coefficient once again is 1. So it's all the factors of 20 over all the factors of 1. What are factors of 20? 1 and 20, 2 and 10, 4 and 5, anything else? No, right? So then all of my possible zeros are 1, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. Now we set up synthetic division and we guess. What is a zero? Because look, we have 2, 4, 6, 8, 10, 12 options. So you could do this 12 times and hopefully your math is right so you don't have to do it 12 times, but we'll see. So we're going to set up synthetic division. I put a 1, negative 8, 11, and 20. I also suggest doing this like if you have a whiteboard or something first before putting it on your paper, like especially if you're in class, grab a whiteboard and do it because you're going to erase a lot and start stuff over. Okay. So what number do you think is a zero of that function? Pick one. That's how this game goes. You want to try 2? Positive 2? let's try positive 2. If I bring down 1, I get 2, I get negative 6. Negative 6 and 2 is negative 12. I get negative 1, I get 2. No, not even close. Because that would give me 22. I need it to say 0. So I know positive 2 does not work. Positive 5? Okay, let's try 5. 5, negative 3, negative 15. That gives me negative 4, negative 20. I get 0. Okay, so x minus 5 is what would work, yes? Because we used, wait a second, let me think about that. Let me think that through. Yes, because we used positive 5, so when we put it in parentheses, it would be x minus 5, yes? Okay. Now, here's the good news. This is now into x squared, right? X squared minus 3x minus 4. How does that factor? X. Good. And then my other factor is x minus 5. So my zeros are 5, 4, and negative 1. Do you see what I did there? Okay, so my zeros are 5, 4, and negative 1. So once you get it back down into the squared form, then you just factor, like you normally would. And if it's not factorable, you have to use what formula? What formula? The quadratic formula.
How do you get that equation?
How do I get what? This equation? Because this is a 1, so it becomes x squared. Negative 3x, negative 4. Because I started with a cube, I took an x out when I did this in diagonal division. So that's how I get that. I just change those numbers. Yep. Yep. Okay, let's try another one. Find all the zeros of 10x to the 4th minus 11x cubed minus 42x squared plus 7x plus 12. I want to find all the zeros. So what numbers do I have to put over top of each other? 12 and 10. All the factors of 12 we listed over there. So they are plus or minus 1, 2, 3, 4, 6, and 12. Yes? What are all the factors of 10? 1 and 10. 2 and 5. So 2, 5, 10. Now, this is where it becomes fun. I have to take plus or minus 1 over plus or minus 1. You get plus or minus 1. Plus or minus 2 over plus or minus 1. See, I'm going to do it with every number. So I get plus or minus 2. Plus or minus 3 over plus or minus 1. Plus or minus 4 over plus or minus 1. 6 and 12. Now, I go plus or minus 1 over plus or minus 2. What's that give you? Plus or minus a half. Plus or minus 1 over, or plus or minus 2 over plus or minus 2 gives me 1, so I don't have to list it again. Plus or minus 3 over plus or minus 2 gives me plus or minus 3 halves, or 3 seconds. Plus or minus 4 over plus or minus 2 gives me 2. I have that. 6 gives me 3. I have that. And 12 gives me 6. I have that. Plus or minus 1 over plus or minus 5. 1/5. 2/5, right?
Yes.
3/5. 4/5. And 5/5, which is 1. 12 over 1 I already have. Or 12, yeah. I'm sorry.
6.
I should have 12 over, or 6/5. Yes, I didn't finish that one. Thank you. And then 12/5. Beautiful. Now, 1/10. What is 2 over 10? It is 1/5, so I don't have to repeat that. 3 over 10, however, has not been listed. 4 over 10 is 2/5, so I don't need to list that. 6 over 10 is 3/5, so I don't need to list that. Well, 12 over 10 would be 3 seconds, right? No. 12 over 10, both are divisible by 2. 6/5, which I already have. These are all of my possible zeros. Now do you see why I say it's a guessing game? Okay, so let's hope we guess right. And yes, fractions can be an answer, so don't just ignore them. Okay?
How do you all this half below it?
I took all of these numbers over top of the one that's below it.
Just divide it,
Yep,
each one by every number?
yep, yep. So, now we list, okay? 4, 3, 2, 1, 0, so I don't need a placeholder. I get 10, I get negative 11, I get negative 42, 7, and 12. Okay? Now, this comes down, what number do you want to try? I say try a whole number first, see if it gets you close or far away so that you can kind of range yourself. So try a whole number first.
3.
3? Okay. Let's look at 3 and see what happens. Oh, this one's a fun one.
Oh no.
If I get 3, then that gives me 30. What's 30 and negative 11 together? Is it 19? 19. 19? What's 19 times 3? What's 57 minus 42? See, look, I already know this isn't gonna work because 15 times 3 is gonna give me a way bigger number here, so I'm just gonna quit, okay? So I know it's not 3. So if 3's too big, we probably should go
2,
lower.
1.
You wanna try 1? Let's try 1. If I try 1, I get this. Negative 1, negative 43. That's gonna be too big still. Yes?
So we should go up?
Mm-mm. You have fractions to work with. What fraction would you like to try?
Negative
4
3.
fifths.
4/5 is not less than 1.
1.
Oh, yes it is, but barely. Why don't you try an easy fraction to work with?
1/2.
Thank you. What's half of 10?
5.
5. What's negative 11 and 5 add together?
6.
Negative 6. What's negative 6? What's half of negative 6? Negative 3. Negative 42 and negative 3 together is negative 45. What's half of negative 45? It's half of negative
Negative 22.5.
Okay, so that's not gonna work, right? Okay, so what, instead of trying positive half, what if we try negative half? Because we were on the right track at the beginning, right, with the 6 getting smaller. So, half of 10 is negative 5. Negative 5 and negative 11 together is negative 16. What's half of 16? 8. What's negative 42 and 8 added together? Negative 34. What's half of negative 34? Negative 17, so positive 17. Yes. 17 plus 7 is 24. Okay. What's half of 20? What's negative?
Negative 12.
And that gives me 0. Now listen, that only took me down to a cube. So I have to do this again. Again, because it took me down to a cube. I can't, and the only way I can factor a cube is if it factors by grouping, correct? Do you think I'm gonna be able to take anything out of here and here to make it the same? No, so I need to do it again. Okay. So, we know that x plus 1/2 works, correct? Or I could write this a different way too. How else could I write that?
X minus 2.
Okay, yes. Or you could write it as, well, it's negative half, right? Or you could write it as 2x plus 1. Either of those are the same thing, right? Because if I set this equal to 0, I get negative half. If I set that equal to 0, I get negative half. So you can write it either way. I'll accept either. Now, from here, we need to plug something else in. Let's try another fraction. Let's try another fraction.
1/5.
Let's avoid 5s and 10s.
3 halves.
Good, that sounds like a nice one. 3 halves. Let's try 3 halves. And since we found out the hard way that a positive half got us bigger numbers, I'm going to just go ahead and try negative 3 halves. So, multiply 10 by 3, you get 30. Divided by 2, you get negative 15. Negative 15 and negative 16 together are negative 31. Negative 31 times 3 is negative 93, right? That should be negative 15, yes. And then put, oh no. Why do I have negative 16 there? I shouldn't have negative 16 there. I should have negative 26 here because I'm stupid at when I added those together. It makes 26. I did something wrong. This should be. Oh, because they did it back from the original again. Crap. They did both of them from the original. I don't like that. This one's a hard one. Okay. If I do it this way, that makes negative 31. 93 divided by 2 is 46.5. I don't know if this is going to work this way. And then 34 minus 44.5 is 12. Yeah. Okay. Yeah. And then it's 12.5. And then 12.5 times 3 divided by 2 is, yeah, it's not going to work this way because they're going to make it, this one sucks. Okay. Because they're going to make this one go back from the beginning, doing synthetic from the beginning, because this one's a weird graph. It's like a W. So, let's try it this other way. Okay, so let's do it this way. Let us change this into grouping. Let's see if it will work. So you have this. You have x plus a half times, and this would be 10x cubed minus 16x squared minus 34x plus 24, yes? What can I factor out of all of that? What number?
2.
A 2. So I'm just going to focus just on this for now. We'll come back to this in a minute. So if I factor out a 2, you get 5x cubed minus 8x squared minus 17x plus 12. Is that right? Okay. So if I do it that way, this is why. I can't group anything here, can I? Because if I group, it's not going to work. I can't factor anything else from there or factor anything else from there. So now, they do the leading coefficient test again. It's like this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 6, 12, 1, 5. And list all the factors and you start over. I'm not going to give you one that this is hard, but it's like that. So you keep going and keep going until you can factor it. Let's look at this one. This one should be easier to factor. Let's factor 48x cubed plus 4x squared. 48x cubed plus 4x squared minus 20x plus 3. So I have 3 over 48, right? Plus or minus 1, plus or minus 3. This is pretty. That's going to be easy up there. 48 is what numbers?
1 and 48.
1 and 48,
224.
2 and 24. What else?
6 and 6.
6 and 7,
6 and 8.
6 and 8, yeah. What else?
So 8.
Anything else? Can 3 go in 48?
I feel like it does, but I don't know what number it is.
16?
Yeah, exactly.
Nope.
You said that.
I knew it was a number, I just didn't know what it was.
What else? Anything else? Did we do 4? Nope, but 4 and 12 do. So we did 1, 2, 3, 4, we know 5 doesn't. We did 6, we're good, yes? So then you would get plus or minus 1, plus or minus 3, that takes care of this. Then you get 1/2 and 3 seconds, yes? I'm gonna do it in order of numbers so that it makes it easier. Then I do 4, so you get 1/4 and 3/4. Then you do 6, so you get 1/6. And you get 3/6, which is 1/2, and we already have that. Then you do 8, and you get 1/8. And then you get 3/8, right? Then you do 12, 1/12 and 3/12. 3/12 though is 1/4, right? So I don't need to put that. Then I get 16, which is 1/16 and 3/16. Okay? Then I get 1/48, or 1/24, I mean. And 3/24 is, that we should have already done, I believe, 1/8. So yes, I don't need to do that. And then I get 1/48 and 3 into 48 is 16, and I already did that. So those are all my options, okay? So we set up synthetic division. 48, 4, this one's gonna be much easier, 23. I will tell you it is a fraction. Because that 1 and 3 is not gonna work. Okay, so look ahead a little bit, figure out what type of fraction do you think it could be? If I take half of 48, what do you get?
24.
24. Plus 4 is 28. If you take half of 28, what do you get? 16. Yeah, that might work. Let's try 1/2. Half of 48 is 24. 24 and 4 is 28. Half of 28 is 16. That gives you
Half of 28 is 14.
14.
Negative 6.
-6. -3. 0. Yeah.
Yes.
So x minus 1/2 is one factor, and then this factors into 48x squared plus 28x minus 6. Can I take anything out of all of that?
Yes. 2, 4. Even 6.
You can't take a 6 out, but you can take a 2 out.
Or 4.
You get to 4 and 6.
6
4,
doesn't
6.
go into 28, right? I can take 2 out of all these, yes? So I can have x minus 1/2 to 24x squared plus 14x minus 3. What multiplies to give me -3 adds to give me 14 with a leading coefficient of 24. So we gotta do a little factoring. I know 1 is 3, 1 is 1, yes? 24, factors of 24, 2 and 12. 12 and 3 doesn't get me there. 2 and, yeah, that doesn't get me there.
6 and 4.
6 and 4, 6 times 3 is 18 and 4 is 14, yes? Beautiful. 6x, 4x, this needs to be positive, this needs to be negative. So, your zeros are x equals 1/2. This would be 1/6. And this would be 3/4, yes? X equals, no, not positive 3/4, so it's negative 3/4, boom. And that is how I do this. It's just going to take time, I know. It's murderous, I understand, it's going to take time. That is what you're working on. And if you know math facts, it's gonna be so much quicker for you. If you're not good with multiplication facts, it's gonna be